Hello everyone, my name is Yongcheng. This is my project. The topic is mechanism of action, which is MOA prediction. Drugs used to derive from traditional ways. With the development of technologies, scientists can create a more targeted module based on the knowledge of biological mechanism of a disease to discover drugs. In order to do this and determine the mechanism of actions of a new drug, large genomic databases can be used to analyze the cellular responses which is treated by the drug. This is a multi-level classification problem. The evaluation score is a log-loss score. And here is data source. This actually is a competition on Kaggle. And here has some more specific detail. And here is some here is a few records of the dataset. And in preparation section, we will look at some data and load libraries and functions. This is a libraries I have used. This is a function for data visualization. This is a load data, and also I reset the index of the data. This is a data of train features. Data of train features contains G feature, which it has about 800 features. G signify gene expression data, and the C features signify cell viability data. It has 100 data, and the CP type contains TRT-CP, which means treatment compound, and the CTRL vehicle, which means control vehicle. And the control vehicle have no mechanism of actions. CP time and CP dose indicate treatment duration and dose. And we total have more than 23,000 data. Here is a describe of data. This is a data of train target scored. It means this is a binary mechanism of action targets that are scored. This is a first five data. And we do the same thing as before. It's a data of train targets not scored. This data is useless, so I will not use this in data analysis. And here's data of test features, which has the same features as before. And this is data of sample submission. So this is a correct format. I will submit the prediction probability here later. In this section is analysis features. At first, I analysis CP type, CP time, CP dose of train features. In the plot, we can see treatment compound is more than 20,000 data, and control vehicle has just a little bit data. The CP time and CP time has 48 and 72 and 24 hours. Only have these three. And the CP dose has D1 and D2. It's has a similar account. Here is gene features of training features. Uh, I use the first five of gene to distribute it, and this is a five random distributions of gene. It looks very the data looks very good. It's this is gene max mean and standard deviation plots. We find that the gene max plot and the gene minimum plot are very symmetrical. Compare those plots with the gene features distribution plots, we find that it might have abnormal data in gene features. We will explore it later. And thus use a same way for cell features of training features. It looks pretty good. And here's cell features of training features. This is test features. We in here, this section will find the relationship between CP type, CP time, and the CP dose with targets. This is CP type is when CP type is control vehicle. This plot shows us when CP type is control vehicle, the corresponding target score is 0. It means this data will be useless. So we will delete the data which contains CP vehicle and column of CP type. For the CP, when CP type is CP, it's very useful, so we keep it. And CP dose and when CP dose is D1 and D2, we can find is the CP dose and the CP time is useful. So we will keep the data here. And in this section, we will use to delete CP vehicle of rows and CP type columns. In another section is we will analyze outliers. For we generate some plots, and it's very obviously when the value greater than 1, it will be outliers, and we will record the data. We analyze outliers here, and we will separate the data to normal and outlier to analyze those data. This do the same thing for gene and the cell of test features outliers. And here is cell outliers. Here we analyze features and targets outlier. We do actually almost the same thing here. And for example, this plot, we plot a gene CP type 24 norm, gene CP time 48 norm, gene CP time 72 norm, and also outliers below. It looks we find the outlier data won't have a significant effect to the original data, so we'll keep use this data. Next, we will explore the correlations and PCA. This is gene features correlations. We can find that gene features are not correlated a lot. For the cell features, we find that cell features correlated a lot. So we do PCA to generate data better. This is a PCA for genes, and after the analyze, we find that 85 gene features represents 89.8% of the data. So we use 285 gene later. And for the cell features, we also do PCA here, and we find that 20 of cell features represents 91.9% of data. And for here, we do 100 encoding to make these features numeric. Here's a data generate. We generate some train data and test data. And for the sixth section, we create a model. We use Keras to create a 3 layers model. For the first layers, we use dropout of 0.3. For the second, we use 0.5. This is a summary of model. Here we will train models. We use Phoebe epoch, and batch size is 128. Verbose is actually we try a lot of parameter here. And in cargo, I use a lot of epochs and use GPU. It takes a lot of time. So in the collab, I don't know how to use GPU, so I just try epochs 50 to save some time. And this is a train. We train here. And the loss is keep reducing. It's getting better. This is a metric I have used. This is test data. Now here's a result. I choose a probability of this features, these targets to sample submission file, and when for example this one, number 2, the value is always 0 because this one is a control vehicle. Yeah. And we also create some tabnet. You can search it here. This one is me and my teammate create the model, and this one performs better than mine. Okay, thank you.